All right, this is an example over lesson 6.6. It's not a problem actually in your textbook. It's one I made up a while ago. Here's the problem. A magazine reported that 6% of American drivers read the newspaper while driving. You can tell it's an old example. Now it would be texting probably, or reading their Nook or Kindle Fire or whatever. But anyway, it used to be newspapers that people would drive. I had a friend that was a salesman. He'd drive down the road reading his Des Moines Register. You know, pretty dangerous, but he'd do it. If 180 drivers are selected at random, what is the probability that exactly 4 read the newspaper while driving? Well, we can think of this as a binomial situation because they either read the newspaper or they don't. 2 outcomes. So that's why it can be thought of as a binomial situation. Now, this is a formula we did last chapter called the binomial probability formula. And the way we did this last chapter, probability of 4 reading the newspaper would mean x equals 4. N would be our sample size, which we have 180 drivers selected. So n would be 180. So we have 180 factorial. On the bottom you have n minus x, so n minus 4 would be 176 factorial. If you randomly pick a person, what's the probability they read the newspaper? 6%, so what would I put for p? 0.06. Yeah. So p equals 0.06. And to the x power, so that would be to the 4th power. Q is the probability they don't read the newspaper. What would that be? 0.94. Yeah, 94% don't. If 6% do, and that would be the n minus x power. So 180 minus 4. So that's one way you can solve the problem. All right. One problem that arises sometimes is sometimes the numbers just get too big and your calculator won't calculate them. You'll get an error that says overflow error or something like that. And sometimes you're not able to actually, you can write out a formula, but you can't get the calculator or computer to actually calculate the answer. The numbers are just too big. All right. I don't know if that happens in this example or not. I haven't actually typed it in. But so what we're going to do today is teach you another way to solve these types of problems. We're not going to use this formula today. Okay. There's another method you can use using the normal curve, since we're studying the normal curve right now. These problems can be solved using a normal distribution if n times p is greater than or equal to 5 and n times q is greater than or equal to 5. So you can only solve, let me erase this because we're not actually going to use this formula. I just wanted to show you we're doing the same type of problems we did last chapter, just a different method.
So you know, calculator won't do that.
Did you try it?
Yeah.
Okay. I think it stops after like 67 point something.
Okay.
I figured it out one day.
Okay. So you can solve these problems, binomial experiment problems, using a normal curve, normal distribution, if n times p is greater than or equal to 5 and n times q is greater than or equal to 5. All right? Otherwise, the data won't really approximate a normal curve. We're not sure enough that we can use that. And some statisticians that know a lot more about stats than you and I probably came up with this rule, and this is accepted among statisticians. So the first thing you want to do here is make sure that those are true. So I'm going to take n times p. So I'm going to take 180 times 0.06. See what that comes out to. Okay. That is greater than or equal to 5. Okay. And then I'm going to take 180 times 0.94. Q is 1 minus p, which is 0.94. And that also comes out to greater than or equal to 5. So as long as both those answers come out greater than or equal to 5, we can use the normal curve approximation. So that means we're going to go ahead and draw our curve, normal approximation. We're talking about 180 drivers. So I want to know, out of 180 drivers, what's the average number of people that would read the newspaper? Well, to find the average, to find mu, the mean, or the average, I take n times p. There's your formula for the average today. If I take 180 drivers times 6%, and that comes out to what, 10.8?
Yeah.
It's 10.8. So on average, if you have 180 drivers, on average, 10.8 of them are going to read the newspaper. Now I realize you can't have 10.8 drivers. You either got to have 10 or 11 or 12, right? We're dealing with a discrete variable. Number of drivers is discrete. It's countable. But we're dealing with a continuous curve and a continuous number line where you can have decimals on it. So because of that, this gets a little bit tricky and you have to make kind of an adjustment. Now to get the standard deviation of a binomial relationship like this, you take the square root of n times p times q. So the square root, I'm going to need some help here maybe, of 180 times 0.06 times 0.94. I might have it on my notes. Let me check.
3.19.
Yep, I have 3.186. That's all right. 3.19 if you round it. Okay? So now I know the standard deviation. I know the mean. I can now figure out the area that I need under the curve. Now, we're trying to find the probability of exactly 4, reading the newspaper. Well, if I come down here, and that's 4 is somewhere less than 10.8. And we're talking about, this axis would be the x-axis again. All right? We're not averaging 4 or 5 drivers or anything like that, so we're just looking at these values being x. If you want to find the probability of exactly 4, you'd have to find the probability between 4 and 4, or find the area between 4 and 4. Well, there is no area between 4 and 4. All right? What you have to realize is that really, if we really were to draw this graph correctly, this would be a histogram. And there'd be a bar right here to represent 4 drivers that read the newspaper. Okay? So to find the probability of 4 drivers, what we really want to do is find the area between 3.5 drivers and 4.5 drivers. That would be the bar that would actually represent 4 drivers. And actually, instead of finding the area of that bar, we find the area of this strip right here. That strip will give us the approximate probability of 4 drivers out of 180 reading the newspaper. So to get that strip of area, we need to find the z-score for each of these values. So to find the z-score for 3.5, we'll do 3.5 minus 10.8 divided by our standard deviation of 3.186. That'll give us that first z-score. To get the z-score for 4.5, we'll do 4.5 minus 10.8 divided by 3.186. That'll give us the second z-score. According to my notes, if you calculate that on your calculator, here I get a z-score of negative 2.29. Here I get a z-score of negative 1.98. Meaning that 4.5 is 1.98 standard errors below the mean, standard deviations below the mean. 3.5 is 2.29 standard deviations below the mean. So let me pause. That's a lot of information at once. Any questions about any of that so far? I calculated the mean with n times p. I calculated the standard deviation here. I figured out that 4 actually means the area between 3.5 and 4.5. I calculated the z-scores for both of those. Any questions?
So then the z-scores are your final answer?
No. I just got a little ways to go.
One more question quick.
Yep.
On the top of the board there, the 180 times 0.06, what's the greater than 5 mean?
It's just, you can only use this method. This method only works for these problems if n times p is greater than or equal to 5 and n times q is greater than or equal to 5.
Okay.
If that doesn't work, we wouldn't be able to use this method.
Okay.
The data wouldn't be considered normal enough to do
Okay.
that. So that's why I was just checking to see if they work. And since these answers are both greater than or equal to 5, I can go ahead and use this method. All right. What's that? You might have to be ready for it. Look at the review packet and you'll know. Review packet. Okay, so what you do now is you find your z-scores on your z-chart. So I'm going to look up the 2.29 first. 2.2, 0.09. This is on your z-chart. So you go over and down. That's going to give you an area. Anybody know what that area is? I don't have. What's that come up to? 0.4890. So what that gave me, since I was using the 2.29, that gives me the area between this line. We get a different color. I just found the area from this line here to the mean. That area, right, from there to there is 0.4890. Next, I'll look up 1.98. So 1.9 here, 0.08 here. I'll come over, I'll come down. Anybody know that decimal? What numbers each start looking up 1.98?
0.4761.
0.4761. So that would be the area right here. 0.4761. So 0.4761 goes from z-score of z-score of negative 1.98 to here. So this is my green area, this is my brown area. How would I find this black area? Subtract. You take your bigger area minus your smaller area, that'll give you that strip. Okay? So if we do that, to find the probability of exactly 4 people reading the newspaper out of 180 while driving, we would write it like this. The probability of 4 people doing that would be 0.4890 minus 0.4716. You don't know what that comes out to? 0.0174, I believe. Subtract those, we did that right.
Yeah, that's right.
Okay? So it's about a 1 or 2% chance that if you go out and survey 180 people, that you're going to get 4 of them that read the newspaper. Any questions about that? What's that say for time on there so far?
12 minutes now.
All right, I'm going to go a little bit longer then. What's the probability of more than 4 reading the newspaper? Well, more than 4, you can't count this area in here because this area is counted as 4. So more than 4, I'd actually have to find the area to the right of 4.5. Anything between, like 4.4 would round down to 4. So if it's more than 4, you'd actually take the area to the right of 4.5, 0.4761, plus the 50% of that over here. So to get this answer, you would take 0.4761 plus 0.5. So there's a 0.9761 or 97.61% chance that more than 4 people out of 180 would read the newspaper while driving. Any questions about that? One more. What's the probability of 4 or more reading the newspaper? You have to read very carefully. You can see I've just changed a few words here. Instead of more than 4, I said 4 or more.
So include the 4?
This time I would include red. If it says 4 or more, I've got to include this black strip, plus the brown strip, plus this one. So really, the quickest way to get more than 4 or more, would be to take this area, which is 0.4890, plus 0.5. So it'd be 0.9890. 0.4890 plus 0.5. So to recap, if you want to find the probability of exactly 4, you find the area between 3.5 and 4.5. If you want to find the probability of more than 4, you have to go for 4.5 to the right. And if you have to find the probability of 4 or more, you go 3.5 to the right. And so I think it's a little tricky, and if you don't draw the picture, it's going to make it even trickier. So I would highly recommend that on this example, you draw the picture. You can turn that on. Thanks.